Hello, Mr. Collier here. This is the last set of notes for Chapter 2. We're going to talk about classifying matter. So one way to classify matter that we're going to look at is whether something is a pure substance or not. Pure substances are things that have a unique set of chemical and physical properties. They're only made of one thing. There's two subcategories of pure substances. One is an element. The smallest part of an element is an atom. And these cannot be separated into anything simpler. Atoms are the simplest thing you get. We represent these by symbols that have one or two letters, like O for oxygen or Ag for silver. And if there are any three-letter symbols, they are temporary, although as of now there are no three-letter symbols, although you might see them on older periodic tables. So here's an example. This is the element hydrogen. It's got a symbol, it's got a name, it's got a place on the periodic table. That's how you know you've got an atom. We'll talk about what all these things on the tile mean in more detail in our next chapter. A compound is another example of a pure substance, and it's made up of two or more kinds of atoms that are chemically combined in a fixed proportion. These are represented by chemical formulas. For example, carbon dioxide, carbon monoxide, water, etc. So these all have formulas and chemical names. But they are very specific ratios, and they are pure things. To contrast that, things that are not pure are called mixtures. There's two types of mixtures: heterogeneous, where they are visibly different throughout and then you can separate them pretty easily. Some different terms: salad dressing is considered an emulsion, chocolate chip cookies, sand, and water, that's a suspension. Suspensions will settle, emulsions may or may not. A homogeneous mixture is the same throughout, so it might be clear, for example, like a Kool-Aid sort of you can see through it situation. And these will not separate out. Kool-Aid, as I mentioned earlier, is a solution where one thing dissolves in another. Milk is considered a colloid. They're not quite dissolved. We won't get into that too much right now. And we can also have alloys, which are mixtures of solids. Mixtures tend to have properties that are in between the things that make it up. So for example, you can dissolve salt in water, but you can't dissolve salt in alcohol. So if you have a 50-50 mix of water and alcohol, some of the salt will dissolve. It's partially soluble. It's somewhere in between because it's a mixture of two different things. Compounds, however, tend to have properties that are totally different than whatever made it up. So for example, sodium is a soft metal that you can cut. Chlorine is a green toxic gas. And when you put them together, you have salt, sodium chloride. This is one of my favorite examples in chemistry of how wonderful it is that two things that have totally different properties when combined can be something totally different. So alloys, as I mentioned, are mixtures of solids. Brass is an alloy of copper and zinc. Steel is carbon and iron. And bronze is copper and tin. These different alloys have different properties because they're mixtures, but the properties tend to be somewhere in between the things that make them up. Gold, for example, is something that is very commonly alloyed to save gold and make things a little bit cheaper. 24 karat gold is truly pure, but 18 and 14 karat gold are slightly different mixtures that have other atoms besides just gold in them. If you look at a microscopic level, a homogeneous mixture will look the same even down at the microscopic level, whereas heterogeneous mixtures will appear obviously different. So here's kind of a flow chart summarizing everything I just said. There's mixtures and there's pure substances. Mixtures can be heterogeneous, not the same throughout, or homogeneous, the same throughout. And pure substances can be compounds made of multiple atoms linked together, or elements made of just one type of atom. There are some different categories within those that you'll want to know as well. And then here's some examples. Here's just one last sort of example of looking at the different elements, compounds, pure substances. The next thing I want to talk about is separating mixtures. So one thing I mentioned is that pure substances can't be separated, but mixtures can be. So one way to separate is through a process called filtration. The stuff that stays behind is called the residue. The stuff that goes through is called the filtrate. For example, sand and water. The water would be the filtrate, the sand would be the residue. Another way you can separate things is through distillation. In distillation, you heat something that has a mixture of different boiling points. The thing with the lower boiling point will boil, and an apparatus like this will allow whatever boiled off to go down the tube get condensed back into a liquid and be collected separately. The thing that you boil off is called the distillate. The stuff that stays behind is called the residue. Here's another look at distillation, and we'll do a demo of this in class as well. Another way to separate things is through crystallization. If you evaporate the liquid and there was a solid dissolved in it, the solid will be left behind. That's called crystallization. So if you have salt dissolved in water and you boil off the water, the salt will crystallize and be left behind. This is also how they make rock candy, a crystallization process. Chromatography is another way to separate a mixture. This is usually done with pigments and ink based on their differences in solubility and their density. So you start out with something like a black ink, and it will separate out into its colors because the different colors ink that make up a black ink are different amount soluble in water and have a slightly different density in that water, and so they will separate out on a piece of paper. Another way to separate something is electrolysis. This will work on a compound, so breaking a compound into its elemental parts. For example, you can run electricity through water and break it into hydrogen and oxygen. And that's it for section 3.